we have to remember the language of quadratic equations. When we're solving a quadratic equation, we're finding the roots of the equation, we're finding the x-intercepts of the function, and our calculator calls it the zeros. You have to feel comfortable with all three of those titles, right? So these are just quadratic equations. This is what you did in grade 11. You solved quadratic equations. This first quadratic equation had a leading coefficient of 1, which allowed you to take your product and your sum and put them directly into the factors. And something that you should always do is before you actually solve for your x-intercept, you should actually just do a quick step check. Is x times x, x squared? Is x times negative 2, that would be negative 2x plus 10x. That does give you the positive 8x. And then positive 10 and negative 2, does it give you the negative 20? Even if you just do a quick mental check, like x times x is x squared, 10 times negative 2 is negative 20. That's not taking you the whole way there, but it's just at least you got the leading coefficients correct. This one has a leading coefficient that's not 1, and so we have to use decomposition factoring. Do you guys remember decomp from grade 10? Okay, so this time, when I'm solving this equation, and this is going to be basically like the last step of every quadratic or polynomial function that you solve is going to be probably a decomp question at the end. So you're going to have about half a page of work. The last little tiny bit is going to be using your grade 10 skills, grade 11 skills to solve a quadratic. But it's about half a page of work that I'm going to teach you guys before that. So let's just make sure you're going to have those last few steps. So when your leading coefficient is not 1, we take 2 times 2. That means my product is 4, and my sum is positive 5. What numbers multiply together to give you a product of 4 and a sum of positive 5? Okay, so 4 and 1. So guys, we have to dive into this question differently than we did this one. We got to just use these numbers. We don't just get to use these numbers. We need to use decomposition. We decompose the middle term. We split that middle term using these numbers. Have I changed my quadratic equation by changing 5x to 4x plus 1x? No, right? And then we GCF the first two terms, and then we GCF the last two terms. What's the GCF here? Do you guys see the 2x? Okay. Now here, there is no GCF. We need to put a plus 1. We need to have a binomial expression, not just a monomial. So we need to actually see that if there's no GCF, I need to put a plus 1 here. When you factor out that GCF, I'm left with x plus 2. Again, there was no GCF, but I need that plus 1 spaceholder. And then I've got my x plus 2. Now this x plus 2 matches this x plus 2. And when I pull it out, the binomial factor that remains is the 2x plus 1. Now this shouldn't feel like it's new to you. Like this is like you guys nailed this in grade 10. You used it extensively in grade 11. I'm jogging your memory, right? That's all this is. But we have to take it one step further. It's not just factoring. We need to set each, these are called linear factors because they're each degree 1 factors. We need to set each linear factor equal to 0, and then we solve for x. So I have to subtract 1 and then divide by 2. So this course, unlike Math 30-2, this course is highly dependent on prior ability. Like you had to come in remembering these skills. Does this look like I just jogged your memory and this is something you can probably take it away now? Hopefully. Maybe I'll do one more. What has to happen on this guy? Yeah. We gotta move, guys, we call these zeros. If we don't see a 0, we have an issue, right? We need to bring the negative 1 over. So I'm just going to add my 1, and then we have 4x squared minus 5x plus 1 equals 0. What gives a product of 4 and a sum of negative 5 this time? Stein, what do we got here? What gives me a product of positive 4 and a sum of negative 5? Perfect. Again, guys, we have a leading coefficient that wasn't 1. So we have to decompose our middle term. And I'm intentionally putting them in this order. because I want you guys to notice something here. If I GCF my first two terms, I see a 4x. When I GCF my last two terms, I notice that this was positive, negative. I need the pattern to also be positive, negative. Right now it's negative, positive. So when I'm looking at the first two terms, it's going to guide my GCF here. I actually have to take out a -1 so I can see positive, negative, and then a positive, negative again. Otherwise, my binomial factors are not going to match. I had to take out the -1, making it positive x minus 1. Now this binomial factor, if I hadn't taken out the -1, the binomial factors would have matched, right? And then we can pull out that binomial factor of x minus 1 and 4x minus 1. So that's grade 10 factoring. And then we take it to each linear factor is equal to 0. Now, does it bother you if I do this in one step and I go straight to 1/4, add the 1, divide by 4? Are we okay with that? Not everyone's okay with that. So how do I get the 1/4? We add 1, and then we get 4x equals 1, divide by 4, and then x equals 1/4. So these, you had a whole unit last year, and it was all about solving quadratic equations, and we did a lot of it. Whether you're in 20-1 or 20-2, there was a lot of solving quadratic equations. So this should be a quick review for you. Now I'm just going to box these. This isn't actually part of a function yet, so I can just say x equals, because there was no y in the original question. These aren't like going onto a graph. Okay, I didn't explicitly state write the x-intercepts. If I explicitly state write the x-intercepts, you need to write them as ordered pairs, right? So there's that decomposition. Make sure you feel comfortable with that. If you can't factor, we would use the quadratic formula. The quadratic formula doesn't go anywhere. It's on your formula sheet up in the top left-hand corner up there. So if you can't factor, we would use the quadratic formula. So when you're looking at this, my leading coefficient is 1. So that means A is 1, B is -4, and C is -4. If you took Math 30-2 last semester, you would get these decimal values. We have to have precise values all the time in 30-1. So it's just going to be a little bit different than what you did in 30-2. So here's your quadratic formula. Here's your clear substitution. You always figure out the numeric value of the radicand, and then you want to simplify your radicals, taking out perfect squares. I saw a perfect square of 16, which turned it into 4√2. And then we have to divide both the constant and the coefficient by the 2 to entirely simplify, and we have 2 precise answers. So in 30-2, you would basically substitute this in and get 2 decimal values, and then you'd be done. We have lots of rounded values in 30-2. And 30-1 has to be precise, always. Okay? So we'll just practice a little bit with the quadratic formula. You always want to check to see if it's factorable first. So is there anything out there that gives you a product of -18 and a sum of 6? So you always want to double check, is it factorable? When I think about -18, I think about like -9, +2, or +9, -2. I think about like -6, +3. I think about +6, -3. I think about 18 and 1. None of these are going to give me a sum of 6. So as soon as I've double checked to see if it was factorable, and it's not, I'm going to get rid of that. So my A value is 1, my B value is 6, and my C value is -18. And I know those of you who had math first semester last year, you're going to need this review. This is my quadratic formula, so -b plus minus the square root of b squared minus 4ac. You don't have to have it memorized, it's on your formula sheet. Your first step is to plug everything in. So I've got, notice there's a negative sign on the b, so the b was positive. It now becomes -6 plus minus. This is 6 squared minus 4 times 1 times -18. I'm going to start opening up my calculator right now because it's going to take a long time. And then I've got the 2 times 1. Now, can I get you guys to please type in everything that's underneath the radical? Can I get you guys to type that into your calculator? Don't type the whole thing in, just the stuff that's underneath the radical. We've got to keep the radical because we're going to have a precise solution, and it's going to include a radical. Guys, what's 6 squared minus 4 times 1 times negative 18? What do we get there? Yeah. 108. Okay. So then x is equal to negative 6 plus minus the square root of 108 all over 2. Now in grade 10, we simplified these radicals, right? Now what are we looking for? We're looking for the largest perfect square that could be a factor of the 108. So when I think about my perfect squares, I know 2 squared is 4. I know 3 squared is 9. I know 5 squared is 25. I know that 6 squared is 36. I know that 7 squared is 49. I know that 8 squared is 64. And I'm going to stop there because I know that if I take 64 times 2, it's bigger. What you want to do is you want to look for the largest perfect square that would be a factor of 108. Which is the largest perfect square that's a factor of 108? Yeah. It's not going to be the 64. That would have been 128, not 108. I'm pretty sure it's 36. Do you guys see that? So when you're looking at the 108, you need to see it as 36 times 3. We can square root the 36, making it 6 root 3. Guys, in pre-calculus, we always want precise values. Does that look okay to you, like that grade 10 skill? So now I've got x is equal to negative 6 plus minus 6 square root 3. And this whole thing is over 2. This is 2 terms. There's a term here and a term here. This is your constant. This is your coefficient. We can't break into the radical. This radical is stuck, and it's going to have a number in front of it. But I can divide both the constant and the coefficient by 2. So then my answer is negative 3 plus minus 3 root 3. And I know that there's a lot of there's a lot of 3's there. This is just 2 different answers. You don't have to do this. One of them is negative 3 minus 3 root 3. The other root is negative 3 plus 3 root 3. And again, this should be reviewed. Yeah?
So you don't have to write.
You don't have to do the 2 steps. I just want you guys to understand that this is actually 2 answers. Does that look? So I'm going to show you the big picture. Jogging your memory, that's all this is, right? Because this course needs you to have these skills. We couldn't factor. We had to go to quadratic formula. We simplify the radicand, right? Underneath the radical, we get a single number. Then we simplify the radical. And then we have to simplify this fraction. Both terms were divisible by 2, so we have to divide by 2. So there's like a substitution. There's a simplify the radicand. There's a simplify the radical. There's a simplify the fraction. Okay? And we're often going to have answers like this at the end of the question. So we're going to have like half a page of work, and then at the very end, if I can't factor, it's going to go to quadratic formula, and then your answer has to be written like this. We never accept decimal rounding unless I specify decimal rounding. Okay? Can I get you guys to try this one? See if you, actually no, you're going to be trying these ones. So let's walk you, there's something about this one I want to draw your attention to. Okay. So, is there anything out there that gives you a product of negative 4 and a sum of negative 8? It's not going to, right? So we know that that's not going to be a factoring question. My A value is then 1. My B value is negative 8. My C value is negative 4. I'm going to plug into this formula, negative B plus minus the square root of B squared minus 4AC all over 2A. Now this time my B value is negative, and there's 2 details I need you guys to attend to, and your B value is negative. Sorry, negative of negative 8. Okay. Guys, what happens to a negative number when you square it? Okay, you should recognize that whenever you're squaring a negative number, it becomes positive, so just turn that to a positive right away. Like that, like don't type it into your calculator. You should know that a negative number squared will be positive, so let's just ditch that negative. And we know that two negatives side by side turn into a positive. And so those are my two details I'm going to attend to right off the bat. Is two negatives makes this positive. When I'm squaring a negative number, it becomes positive anyway. So let's just ignore that negative in there. So figure out your radicand first. So I've got 8 plus minus. The stuff underneath the radical, we need a single value there. What's 8 squared minus 4 times 1 times negative 4? Your calculator does the order of operations for you. Did you guys get 80? Yeah. Okay. Now let's think about this 80. Let's think about the list of perfect squares. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared, 2, 3, 4, 5, 6, 49, 64. Guys, what's the largest perfect square that would be a factor of 80? Like until you feel like your radical skills are fresh again, you might want to give yourself that list. Brody, which one? Totally going to be 16. So when I'm looking at the square root of 80, it's the square root of 16 times 5. I can square root the 16, making it 4 root 5. And again, simplifying radicals from grade 10, merging it with quadratics, that was grade 11. So skills you should come to class with. And I'm just jogging your memory. Now, are 8 and 4 divisible by 2? Yeah. So I'm actually just going to divide each term by that 2. And I get 4 plus minus 2 square root 5. And there's my 2 precise x-intercepts. Do you guys know how to check this? Take out your calculators. You take out your calculators and just type in the equation in your y equals. We know that when we're solving a quadratic equation, we're finding the exact x-intercepts. So if I put x squared minus 8x minus 4, and I take a look at the graph, if I use those answers, okay, so if I take a look at my answers right here, my answers were 4 plus minus 2 root 5. If I just push trace, and if I put 4 minus 2 square root 5, okay, that was one of my answers, right? So it was 4 minus 2 square root 5. I just got y equals 0, right? If I push trace again, 4 plus 2 square root 5. So your calculator wants to give you rounded values all the time. You have to find the precise values, and you can verify it with your calculator. And I can see the y is equal to 0. Yeah? Because when we're solving a quadratic equation, we're finding the x-intercepts, or where y was equal to 0 on the quadratic function. Okay, so we have like 6 mixed practice questions right here. So what it is basically it's 6 questions where it's either solved by factoring or solved by quadratic formula. Always try to solve by factoring first, and if it's not factorable, then go to quadratic formula. I want you guys to take just a little bit of time right now and just practice your factoring on 6 questions. Ladies and gentlemen, do all 6. If they felt good, you don't have to review this. If it didn't feel good, you might have to, like I said, YouTube videos, whatever it takes to make sure you've got those skills. But you have to know how to simplify your radicals quickly and efficiently. That's like your basic times tables in pre-calculus. Okay, so what we're going to do is we're going to start talking about the characteristics of a polynomial function. And so we've actually done polynomial functions. We've done 2 of them before. In grade 10, we did linear functions. In grade 11, we did quadratic functions. And they're part of the bigger polynomial family. So a polynomial function, so this is actually like a really nasty way of representing it, but this is often the way we represent expressions. And this is like an expression for all polynomial functions. The a's represent the coefficient on the power, okay? So when I look at this, this is degree n, because the exponent on the x is an n, and so I would say that's the nth degree, okay? The subscript on the a is just like an a subscript n. That's just saying the coefficient of the power that had an exponent of n is this. So this is an exponent, this is just a name, okay? So for example, if I said p of x is equal to 4x to the fifth plus 3x to the fourth minus 2x cubed, this would be my coefficient when my degree was 5. So this is like my a subscript n, and then this was x to the power of n. This is just telling me the name. This is the coefficient that was on the x to the power of 5. It's the coefficient that was attached to that a value. So you have to kind of learn how to like interpret like a general expression for all polynomials. Now here's some information that you need to recognize. When you're dealing with a polynomial, the polynomial is defined by the power. That's your degree. So when we're the nth degree, your n has to be a natural number. Guys, what are natural numbers? Except, yeah. Sorry? Okay, it has to, well, whole numbers actually include 0. And technically this could include 0, but your natural numbers are your natural counting numbers. So 1, 2, 3, 4, 5. And we won't go higher than 5. So when you see an exponent, you're going to see that the exponents are all natural numbers. They don't have a radical on them. They're not going to be negative. They're not going to be fractions. They're going to be natural numbers. So remember that natural numbers are your natural counting numbers, okay? These are just represent coefficients. Don't worry about the a to the subscript n minus 1 or anything like that. They're just coefficients, and they could be any real number. Real numbers are basically any number you know about. Any real number could be like 1/7. That's a real number. It could be 1.2. That's a real number. Pi is a real number. Root 2 is a real number. Any number you've been exposed to throughout 12 years of math would be considered the real number system. There is a system called the imaginary number system. You don't even know what that is, so don't even worry about it, okay? The coefficient of the highest power is called the leading coefficient, okay? So the coefficient of the highest power, so you look for the highest power. If it's degree 5, the number in front of that would be considered the leading coefficient. If your highest power is degree 3, the number in front of that would be your leading coefficient. And then again, the degree of the polynomial is the greatest power of x. So, grade 10, you guys dove into linear functions. Grade 11, you dove into quadratic functions. Now, grade 12, we're going to take those 2 functions and we're going to turn it into 6 others. So you're going to have to be comfortable with 6 polynomial functions. If you took 30-2 first semester, we only had 4. We're taking it to 6 now. Okay? So the constant function is a polynomial function. Some people say, well, that'd be like 2 times x to the power of 0, but we can't see the exponent of 0, so we don't say that that's part of the exponent family. Guys, what is x to the power of 0? 1, right? X to the power of 0 is 1. So you could see the constant function. If there's no x at all, you call it degree 0. Now there is no leading coefficient because by definition a coefficient is attached to a variable. Do you see a variable? No. So this one does not have a leading coefficient. It does have a constant term. A constant doesn't have a variable attached to it. It does have a constant term. So now, when you guys dealt with quadratics last year, what did you know about the constant term with quadratics? Do you guys remember? What did the quadratic constant term give you? What did the linear constant term give you? Do you guys remember at all? The constant term is always going to give you your y-intercept. Guys, when I say y-intercept, what are you thinking? You should be thinking x equals 0. Okay, if I put zeros, if I put a 0 in for this x, it'd be 3 times 0 minus 4. What are we stuck with? The negative 4, right? So when you're dealing with the constant, that's actually your y-intercept. Do you guys know what this y equals 2 looks like? Yeah. Straight line. Y is equal to 2. It never deviates from 2. It doesn't go up from 2. It doesn't go down from 2. It's just always 2. If it's always 2, your y-intercept would be 2. Yeah? Okay. So what degree would this be? If there's no exponent on the x, but we can visibly see an x, it would be degree 1. So this is degree 1. My leading coefficient is the number attached to the highest power. So my leading coefficient here is 3. And my constant term is negative 4. That's going to give me my y-intercept of 0 and negative 4. Now this is quadratic, so this is review of grade 11. What degree would this be? I see a degree 2 and I see a degree 1 power in there. We just take the highest power, that's your degree. So this is degree 2. The leading coefficient would be a 2, and my constant term would be a 5, and the constant term gives us our y-intercept. So this is cubic. You guys are going to need to know the names. So this is constant, linear, quadratic. This is cubic, so it's a cubic function, and the cubic functions have a degree of 3. Guys, what's my coefficient on that x cubed? Yeah, 1. If there's nothing there, it's assumed to be 1. What's my constant term here, ladies and gentlemen? Santi, what do we have for the constant term?
3.
It's totally 3. That means we're going to have, like, if you want to think about it in terms of y-intercept, that's 0 and 3. If I put zeros into all these variable terms, I'm stuck with 3 at the end. Like, you should see that y-intercept. Okay? The next one is called a quartic function. So that's degree 4. My leading coefficient here is 1 again. And my constant term is 6. Do you guys see those? Okay? And then the last one would be degree 5. What's the coefficient? What's the leading coefficient? It's going to be 1. What's my constant term? Yeah. 0. If there's nothing there for a constant term, we would see it as a plus of 0. So we're going to go from 2 polynomial functions to 6 polynomial functions.
If you put 9 for that, would you get it close here?
Sorry, say that again?
If you put 9 instead of 0, that'd be wrong.
That's wrong. Yeah, you can't graph none, right? Like, so it would have to be like 0, 0. You can't graph none. So these constants are telling you y-intercepts, and there's no such thing as a, yeah, does that make sense? Okay, so we need to remember that every polynomial function has natural numbered exponents. They're going to have coefficients, and the coefficients can be any number. We call the leading coefficient the one that's attached to the highest power, and then we can figure out our degree. So now the question for you is, and so these are my questions for you, is this going to be a polynomial function? So each question, so we're just going to ask the question, is it a polynomial function or not? By definition, if it is, you've got to tell me which polynomial function it is. Guys, with the 2x to the power 5 minus 3x minus 4, is that a polynomial function? Yeah. I see a natural numbered exponent. I see real coefficients. Everything looks good. So yes, but which polynomial function is this? This one is a quintic degree 5. Okay, let's look at the next one. Is it a polynomial function? Library. Yeah, okay. So it's not a polynomial function, and the reason why is because we have an exponent that is not natural. So it's not a natural number. Okay, let's look at the next one. So we have to interpret, is it a polynomial? Is this a polynomial, ladies and gentlemen? Okay, your knowledge of exponent laws matters quite a bit right here, okay? It looks like the exponents are natural numbers, but this is this should be throwing you for a little bit of a loop. If I wanted to work on this in a meaningful way, and if I know my negative exponent laws, I would know that if I brought this up using my negative exponent laws, it would be x to the negative 2. 1 over x squared, grade 10, exponent laws. You're coming to class knowing your grade 10 exponent laws. You should know that a fraction, a variable on the bottom, can be brought up to the top using a negative exponent. So, is this now a polynomial function? No. Okay, so no. And we have a negative exponent. But it was a sneaky negative exponent because you guys had to know your exponent laws from grade 10 and know that 1 over x squared is technically x to the negative 2. Like if that seems foreign to you, then that's something else you might need to review. Is like, okay, well I have to look at my exponent laws. Okay, what about this one? This is a quartic function. By definition, a polynomial function will have natural numbered exponents, and the coefficients and constant will be any real number. Is this a polynomial? It actually is. It's okay to have a root 6 as your constant, so yes. What do we name this guy? Yeah. It's quartic. So it's quartic degree 4. Okay, looking at the next one, do you guys think that that one is a polynomial? Guys, how do we work with that square root of x in a meaningful way? Using your exponent laws from grade 10, the square root of x could actually be written as an exponent. Does anyone remember what the square root of x is as an exponent or as a power? Okay, I'm going to show you, and this is actually a no, okay, but I'm going to show you why. The square root of x is actually x to the power of 1/2. Now here's the tricky part about exponent laws, is that you guys hit them really hard in grade 10, and then we don't hit them hard enough in grade 11 for you to really remember them in grade 12. But something that you guys need to remember is if I have the square root of x, that's x to the power of 1/2. If I have the square root of x cubed, that becomes x to the 3/2. So the exponent, the index of your radical becomes the denominator of a rational exponent. Okay, so that's actually an exponent law from grade 10. So if I rewrite this using that exponent law from grade 10, is this a polynomial function? No, because 1/2 is not, it's not a natural number. So no, we have a rational exponent. And rationals are fractions, right? We don't want fractions for our exponents. Now, if I were to send you guys to the whiteboards, would you guys be able to expand this whole thing? Okay, maybe. If you were to expand this whole thing, what would the exponents be? What would your highest exponent be? It's going to be 3. Do you guys see that? So let's think about this. It doesn't matter what happens in between. If I take x times x times x, that's going to be y is equal to x cubed. And then dot, 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 I don't care what happens in the middle. If I take the constants and multiply them, guys, what's -5 times -7 times +4? 140. If I were to expand this, would I ever get a negative exponent on the x? Would I logically, if I'm going to take x times x, or negative 5 times x, or if I do any sort of expansion, would there be anything that would indicate a negative exponent or a radical exponent? Okay, let me just show you guys real quick what this